Hello and welcome. Thank you for joining us for our sixth webinar in our series, The Hardware Marathon. We're looking at the phases and some of the obstacles encountered in developing a hardware product. If you missed our previous episodes, we've looked at how to utilize iterations to your advantage, the importance of using a physical representation to communicate your vision of the product, several tools to protect your intellectual property, elements to consider in developing your best minimum viable product, and in our last episode, we looked at how to transform the MVP into a manufacturing-ready product. You can find these on our YouTube channel if you weren't able to join us. Today's webinar is the beta phase in our marathon. Beta is focused on wrapping up the design activities so that the product can be released into production. Lots of details have to come together before a product is ready for manufacturing, such as finalizing the design. You need to have your drawings done and a complete bill of materials. You need to pass regulatory and certification testing if that's required for your industry. And obviously, you need to identify and qualify your supply chain if you're having things manufactured outside of your facility. And that's just to name a few of the things that have to come together. We discuss these and more in the blog associated with this phase on our website. In our discussion today, we're going to explore one topic within beta, production tooling, specifically for plastics. For those who haven't attended previous webinars, my name is Jenney Loper. I'm the Director of Operations at Zebulon Solutions. I've been in manufacturing since the age of 6, working in my father's machine shop. After completing my degree in physics, I've held positions in every aspect of developing a product, from research to design to testing and scaling production to over 40,000 units per month. Most of my career has been working with a product after it's been designed, and I have over 2 decades of experience in manufacturing, quality, and supply chain management. In my current role, I have a lot of conversations with people developing their product for the first time, which is really the basis for creating this webinar series. Today, I'm joined by Joe Steinman. He's the lead mechanical engineer here at Zebulon Solutions. Welcome, Joe.
All right, thank you. During my career, I've worked for over a dozen startups as well as some larger companies, designing and bringing to market products ranging from automotive and aerospace to robotic toys and telecom equipment. To be successful in product design, I've had to learn about agency testing, product release cycles, tooling design, and production wrap, while fostering vendor relationships along the way.
Well, Joe, I'm glad to have you join me today for this conversation. So, and since this is the beta phase, one may wonder why we're talking about production tooling. Well, generally, during beta is when tooling is started and qualified because regulatory testing needs to use production quality parts. Even if you're not in an industry, in regulated industry, it still really helps to mitigate your risks when you're going into production. So our topics today, we're going to look at 3 different things. We're going to look at the different types of injection molding tooling that is used for production, what to consider when evaluating where to set up manufacturing, and lastly, some common design pitfalls and how to best design plastics for production. We would love it if you all in our audience would engage with us during this event. If you have comments or questions, feel free to put them in the LinkedIn window. They'll show up there, but they'll also show up here in the webinar. We will pause for questions after every section, but if a question comes up during our conversation, go ahead and ask it. We'll try to wrap the questions into our discussion. So with that, let's go ahead and get started. So as we move towards production, we move farther away from additive manufacturing and 3D printing. And that's in most instances. These prototype processes are great when you need to iterate quickly and you only need to make a few parts. But when the quantity of parts needs to increase and your iteration frequency is decreasing, there's generally a shift towards production quality tooling, because the individual cost of each part can be substantially reduced using injection molding versus 3D printing. The parts are created in seconds, not in hours. One note about terminology. Since we are starting to talk about production, there are some terms that we may use that may be not well understood by you all if you're not familiar with manufacturing. I'm going to try and highlight these, but if we use an unfamiliar term, or if we use a term in an unfamiliar way, go ahead and ask about that, because I'm sure you're not the only one with that question. The first word I want to start off with is volume. Usually we're going to talk about this as the number of parts that are being produced. It has nothing to do with the physical size of part that is being produced. So I want to get that started. The other thing we had to get in the room is I don't know how familiar our audience is with the injection molding process. Could you do a quick overview?
Sure. Injection molding basically is forcing melted plastic into a tool that's been hollowed out into the shape of the desired part. Requires a press that melts and forces the plastic into the tool in a mold that has a cavity the shape of the part.
Great, thanks for doing that. One other term that we're going to use is the word shot. Usually we're going to talk about the number of parts that a tool can make, but that's assuming that you're only going to make one part per shot. So we may say shot instead of part, and it's really just when the machine will open and then it will close and it's going to make a part, or it's going to make a shot and then open again. Whatever you take out of the machine is that shot, and it could be one part, it could be more than one. We'll talk a little bit more about that later. So with that as set up, let's get into this first topic and look at the types of tooling used in production. So Joe, could you give us a quick overview of these two different types of tools?
Sure. First, you have bridge tooling. It's intended to fill the gap between prototype and production. And, they're typically built out of softer materials. They're quicker to fabricate, they wear out quicker. There's concerns about holding tolerance, and as such, are only really designed to produce lower volumes of parts.
So when you say softer material, what kind of materials are you talking about?
Typically aluminum or softer grades of steel that are easier to machine. The emphasis is really on time to create the tools and get them.
Great. Could you estimate how many shots or parts you can get off of a tool?
Well, there's no hard answer, but somewhere in the tens of thousands.
So it's a soft answer. No, just kidding. All right. Anyway, so if someone was expecting the total life of their parts to be like 30,000 parts, they could probably get by with using a bridge tool that would be cheaper to produce if they could take the wider tolerances for their product.
Yeah, that's correct.
Okay, great. Well, hopefully that helps our audience have a basic understanding of what the bridge tooling is. If you still have questions, feel free to put them in the chat and we'll try and get to them here in a minute. Let's talk about production tooling.
Sure. Production tooling is intended to produce a higher volume of parts. They're made from hardened steels. They can maintain tight tolerances over the life of the tool. And they may be automated to remove parts and do some secondary operations.
Got it. I'll put you on the spot again. How many parts can you get off of a production tool?
Oh, hundreds of thousands.
So definitely for all of those high volume products that people are thinking of.
Definitely.
All right. Well, hopefully these differences help our audience understand what the differences, how these different types of tools work. Let's see if we have any questions. 1, 2, 3. I think we're good. Okay. Everyone has a crystal clear understanding then. We're going to move on. All right. So let's talk about other types of tools that are possible within the production tooling world. Could you do a quick overview of what's on the screen?
Sure. A multi-cavity tool is a tool that can create multiples of the same part at one shot. Overmolding, multi-shot, and insert molding are tools that that produce a material, a part of mixed materials, be it plastic and silicon, or metal and plastic.
Did you bring a sample of one of those today?
I did, sure. This is a part that has been multi-shot. The green is the initial shot, and the black is the secondary shot, which is a softer plastic.
Okay, great. And they just look like one part when you have them together then?
Yes.
Gotcha. Okay, great. Sorry I interrupted you there.
No problem. So family tools are parts of similar size and physical volume that can be bolted together over time. And the mud tool is a master unit die. Excuse me. These are inserts that are swapped out for parts of similar size and they save time and money in the tooling and manufacturing. Excuse me.
I'll let you take a quick drink there. Yeah, so I think that that's kind of a good overview of it, and that might have a lot of new terminology. If you do have questions about that, we'll try and capture that here in a second when we pause for questions. Let's see. Where's our next slide at? Okay. You know what? Actually, this is probably a good place to take a pause now that I'm thinking about things. We did have one question come in about bridge tooling. The question from Leah Jean is, how much tolerance is lost over the life of a bridge tool? She has a product that she needs to hold within 1/1000th of an inch, and she would have issues if the bridge tool lost that degree of sensitivity.
Sure. There's no hard answer. Obviously, aluminum is going to be softer than steel, so I'd tend to migrate towards a steel tool instead of an aluminum tool. But it's really dependent on the material that you're using, the number of shots that you expect to produce, and like I said, there's no real hard answer.
So if you have somebody doing some really good maintenance on a bridge tool and they would keep a close eye on that, then you might be able to get by with bridge tool?
It depends. I mean, small features will get lost over time. Larger features, less likely. And so, yes, you're going to have to watch the tool. And if the tool is designed with inserts for these fine features, then they can be removed and replaced and add length to the tool itself.
That's a really good point about being able to swap out inserts and get it. So probably, I mean, the good answer on this, it really depends on what the design features are and what the overall product is.
Right.
So I would say if you want to have us look at your product specifically, go ahead and just reach out to us. We can talk specifically about what features you're concerned about. So is there any other questions coming in? Let's see, one more question. Leah Jean, would the tolerance change degrade over 1/1000th of the inch over the life of the tool? So the first shot versus the 10,000th shot.
Probably, yeah.
So
I mean, it's the tolerance. The tool is always going to produce repetitive tolerances. The problem is that your dimension will shift over time, not so much that your tolerance will change.
Got it. So you're going to move your nominal off of center or wherever.
Right.
Got it. Okay. All right. Hopefully that helps, Leah Jean. All right, we're going to go ahead and move on to our next section, I think. And let's take a look at where we're going to do manufacturing. So this is probably one of the bigger questions that come up when people are trying to figure out what to do with manufacturing or production is where they're going to do it. Let's first acknowledge that you don't need to make the tools and the parts in the same location. You could make the parts and the tools domestically. You could make the parts and the tools offshore in a foreign location. You can make the tools in a foreign location and the parts domestically. I don't know of a scenario where it would make sense to make the tools domestically and the parts offshore. But if you know of a scenario, I would love to chat with you about what that situation is offline sometime. Joe, what are your thoughts about tool and part production?
Sure. The main issue is who owns the solution to defective parts. If is it the tool maker, is it the part producer, and basically you don't want to get into a pointing the finger contest between the two.
Yeah, that's no fun because you're in the least position to be able to fix anything. So yeah. All right. What if you do end up making the tool in a separate location from the parts, even though that has got risk associated with it? What needs to be considered?
Yes, sure. The real thing is, can the tool be moved to another supplier? Different machines take different types of tools, different tool design approaches, and impact to production with transportation and bring up of the new tool from the foreign source.
Absolutely. Yeah, I mean, it is definitely risky. I've done this several times in my career where we brought tools that were made overseas and actually even in production overseas. And then for various reasons, the customer wanted to bring them to the U.S. I would say that there's more success if you're working with a molding house that frequently takes tools from overseas versus someone who has never taken overseas tools, because they've at least seen what kind of adaptations and also what kind of tools they can accept versus what kind of tools they can't accept. So, yeah. Well, speaking of risks, let's look at some of the pros and cons about manufacturing in the different regions. And I'm going to wait for this slide to go up on the screen because there's a lot of information on it. And I would say in this information we put up here, we probably didn't capture every aspect that should be considered when you're looking at going offshore or doing something domestically. If you in our audience have something on here that we didn't capture, go ahead and put it in the chat and have a quick conversation about that. But looking this information over, I don't think there's anything that's too surprising here. Domestic manufacturing is higher in cost, but everything else is much easier versus offshore that is the exact opposite. However, the cost savings that offshore offers is frequently so significant that many companies choose to go offshore and just deal with the rest of the challenges. Joe, what would you highlight here?
Sure, two things really, and I've done a lot of tools or product offshore, so it's really understanding the cultural risks of the country you're dealing with. For example, in China, all IP is owned by the government. As such, it's available for Chinese nationals to use. Unfortunately, this applies in practice to any IP, whether owned by China or not. And secondly is be prepared to spend time at the molder in order to approve final parts and convey accept region criteria.
Yeah, we're going to say that more than one time, how important it is to go to and be at the fabricator. So, yeah, and is there anything else that came in? I don't think so. I will say we also put up on our list here so the comparison with going near shore, such as Mexico. You can mitigate some of the risk of going completely offshore and still able to take advantage of those lower labor costs. But regardless of the solution that you choose, you really need to weigh the pros and cons for your business. So if offshore does make sense, then the challenges become, how do you find a manufacturer? A quick internet search will usually bring up a plethora of brokers, which introduce several other risks. Joe, I know you've worked with a lot of brokers. What's your experience been?
Sure. Yeah, you have to understand that a broker does not have their own facility. As such, they're free to send out the work to whomever they want, and this may vary from one order to the next. You never really know who's fabricating the part at any given time, what their quality standards are, if they're even using the correct material. The main thing is really get to know who your supplier is.
That's the underlying theme. You got to know who you're dealing with, regardless of where you are. A couple other things to take into consideration is transport time. Obviously, if you go offshore, it's farther away, and it's going to take longer, and it will add some more cost to getting product airshipped here. You can do ocean freight, but for plastics, unless you're making really large plastics or a lot of plastics, it doesn't necessarily make sense to do the ocean freight. So air freight usually makes sense to do that. The other thing is import costs. Tariffs seem to be an ever-changing landscape. Really get to know a good importer and have them manage all of those changes in legislation that seem to be continually happening these days. One comment I do want to make about cost. When you're doing cost comparisons to overseas versus domestic, you really need to look at the total landed cost, including freight and tariffs, and not just look at the unit price or the cost of the tooling. Because if you're going to be doing this for a number of years, you need to decide if the total landed cost is really worth the cost of shipping it in here as when dealing with tariffs. The last topic we're going to cover in this particular section is about the necessity of visiting suppliers. We've mentioned this a few times, get to know the suppliers. And that's the best way to help mitigate some of that risk. It's difficult to know if what you're being told is reality unless you go put your eyes on the production line. And there's nothing like seeing what is actually happening on the production line, what that production line is like, who is actually involved in the process. And if you're using a broker, even if you go over once and you see what it looks like, a broker can completely change that scenario the next time you go over for various reasons. What have you found beneficial about supplier visits?
So the key thing here is really being able to build a relationship with your supplier, get to know who they are, both from a technical standpoint and a business standpoint. They are the experts and they know how to do tool design and resolve issues that you may have in the process.
Yeah, you can learn a lot from the experts. I know that you gained a lot of information just by talking to the people who are actually making the tools. Yeah. We're going to pause here for questions. Does anyone want anything we need to specify or go into more detail about on choosing manufacturing locations before we move on to our next section? Let's see. That has to go down to read it. I can't. So, all right. How can you tell the difference between a broker and a manufacturer online?
Oh, that's a tough one. Really, it's a function of trying to understand if they have their own facilities or if they're just a facade saying they can go in.
Yeah, it's really tricky. I mean, even for us who do a lot of supply chain work, I know I've been tripped up by more than one broker making an amazing website. So usually I find that usually when you start talking to the individual, you can figure out if they start talking about the factory versus the partners or things like that. There's some key words that you can hear in the conversation, but just do an internet search. It's really tough to figure it out. Any other questions? Eugene, I'm glad we were able to help you on the last one. Thanks. Let's see. Can you leverage third-party services to go to the factories for you instead of visiting yourself?
Yeah, yes, you can. There are third parties that can do that, both domestically and overseas. Again, it's hard to find those and find those that do a good job for it is possible.
Yeah. I've actually never used them, but I've known a number of people who have been successful in hiring that out, being able to have some eyes in China on what's going on.
Right.
So, yeah. All right. Well, let's go ahead and move into our last section today and talk about some common design pitfalls and how the design can help avoid those design issues. So a couple pictures we're going to put up here on the screen in a minute are things that are very common in every injection mold. So let's talk about gates, again with terminology. So I put a circle on the left-hand picture around the gate. This is where the material is flowing from the molten part of the mold into the actual part itself. On the right-hand side, you can see the ejector pens sticking out from the mold. I put a little circle around those as well. And that they're there just to help get the part out of the mold. Both of these gates and the ejector pins have the potential to create cosmetic or dimensional defects. Joe, how do you handle dealing with these common features?
Sure. Gates and ejector pins typically are going to be managed by the tool maker with input from your engineering. The key here is to locate them obviously in a non-cosmetic area if possible and to minimize the size and effects because there's going to be a blemish there regardless of where you place it.
Gotcha. Yeah, I think to the point you made, you're working with your mold manufacturers, get to know them because they'll tell you what they need and you can tell them what you need and find a compromise. Yeah. All right, let's move on to the next one. So these are a couple pictures that I took on a production line a few years ago. The picture on the left is actually a clear plastic. I mean, the beads are about that big around. They're very tiny, and that would be used to make a clear part. If you were making a black part, those beads would be black in color, and so the beads really are the same color as the parts are going to be. That's what they look like before they go into the hopper to be melted. Joe, when you are selecting material, what things do you consider?
So I look at function and design of the part. An example would be thin walls versus thick walls. A part with thin walls requires plastic that's going to flow into those features very easily. Part with thick walls is less taxing on that. Also, I look at the environment where the parts are used. If it's high temperature, low temperature, you're going to select plastics based on that as well.
So design features, and then obviously what the function of the part is going to be, your guides the material selection. The picture that I have on the right is actually the remnants that are clipped off, that are left after you take the parts that are clipped off from them. So the mold material has to flow from the molten heated region of the mold into the cavities where they're actually formed, and you get these little trails, and then they could be any color, whatever color you're shooting would be what color these runners and the gates are. Joe, do you want to talk a little bit about how mold flow factors into your just how they can create defects?
Sure. I mean, doing mold flow analysis is really beneficial in that it can help determine gate size and location for best fill, whether the part's actually going to fully fill based on parameters that you define, short shots, whether the part will fill and the air inside the tool will evacuate. Sink locations are basically divots on the part that would be due to extra thick areas that cool at a different rate than the rest of the part. And knit lines, which are marks set where the plastic flows around an obstructional hole in the part, for example. When it joins back together, it creates a knit line or a weld line. And if the temperatures aren't correct, that could be a point of failure on the part.
So there's a lot to take into consideration beyond just what the part looks like, but thinking about how that plastic is flowing in and around the part, and cooling temperatures and air escapes and all that kind of stuff. So
right, and the molder, the toolmaker molder has some pretty good insight into how to alleviate or mitigate some of these issues.
All the more reason to get to know one really well. Right. Okay. Let's go on to our next slide here. So sometimes the only way to confirm the parts are designed for molding is really to put them into the mold and see how they're running. But we're running a little bit short on time. Would you pick out which one of these is the most difficult that you found to address?
So really, warp and twist is a difficult thing to address because it's going to be how the part fills, where your gates are located, and how far away the plastic has to flow in order to fill the tool. And it can cause, because the plastic's cooling as it's flowing through the tool, it may cool too quickly in one area and still be molten near the gate. And so as it cools, it's going to cause that to twist.
So if you've got a part that requires some flatness to it, this can be a little bit of a challenge figuring out where to get your gates positioned to avoid that problem.
Correct.
And then minimize the cosmetics and all that. There's so many things to take into consideration there. All right, well, thanks for sharing that information. This is I think the end of the information that we were planning to share on this. Let me see. I think this is the end. There's one more slide. Oh, we do have one more slide. Sorry. So with the advent of 3D printing, it does make impossible to mold parts possible to exist in the world. I know a lot of the projects that you get need to be redesigned because the people have been printing them and they want to get them into injection molding. Could you talk about some of the changes that you frequently need to make?
Sure. I mean, the biggest change is that the parts don't have draft angles. Draft angles are like an ice cube tray where, in order to get the part out of the mold, you need an angle so that the part will actually release and not have features that it'll hang up on. Key thing there is that with no texture or polish finish, you can get away with a smaller draft angle than a very highly textured finish. Undercuts are basically where the mold won't pull apart because the plastic is such that it creates little hooks in there. TPUs and silicons, you can get away with it because they're flexible enough, but for a more rigid plastic, it's going to cause breakages of the plastic and really necessitating adding slides or lifters to the tool, which of course, impacts the complexity of the tool, the cost of the tool, and the cost of the piece parts.
Yeah, I know when you start talking about slides and lifters, that adds tool complexity, it adds tool maintenance, and it can impact tool lifetime. And so trying to figure out how to get things molded so that you don't have those really helps to provide the most cost-effective tool over the life of the part. Okay. All right, we did have a question come in about defects on the last slide, about examples of each defect. That is a great idea. We actually did try and spend some time trying to find some defects. Unfortunately, we don't get to hold on to the defects, and so we've had to give back parts. But Jessica, why don't you reach out to me, and I can probably point you in the direction of some sites that would have some of these defects identified, and we'd be happy to have that conversation with you separately as well. So. All right, I think that this is the end of the material that we had prepared today. Are there any other questions from our audience? And while we're waiting for questions, let me just share a few of the insights that are coming in. Some of the insights that we had, goodness, my brain is stopped for a moment, is that really the number of parts you need to make and the part quality is going to dictate the type of tooling that is needed. We also talked about that every manufacturing location has its benefits and challenges, and it's important to weigh the pros and the cons before making a decision. And then lastly, effort should be given to design the parts so they can be manufactured to avoid part defects as much as possible. So I know we have a couple questions here. The first one is, do all molders do mold flow analysis?
So the simple answer is no. If you're dealing with a good reputable shop, they should have it available, but you have to ask for it and see what they actually can produce. Mold flow is not a cheap tool, so the lower end shops typically not have it.
Do you work with molders that don't have mold flow analysis?
It depends on what's being molded. If it's a straightforward part that is pretty easy, you don't need it. It's more so on complex parts where you really want to use it.
So if you've got a lot of mixture of thin walls and thick walls, or corners and knit lines and all that kind of stuff.
Right, yeah, large parts. Yeah.
Yeah. Okay. All right. Let's see. Another question. Let's see. How are production tools designed for automation?
So really, the simplest thing is having a robot remove the part from the tool. But it could be a part that has two shots that the tool base will rotate between two presses in order to do the two different materials.
So kind of like what you have with the sample that you
Right.
would put in one.
This was a low enough volume part where it was hand picked out of the tool and then placed into another tool.
Gotcha. All right. See any other questions for the day? Don't see any there. All right. Well, I hope this was beneficial for everyone who attended, and thank you all for participating and asking really thoughtful questions. Joe, before we wrap up, is there any insight that you want people to walk away with?
Yeah, it really boils down to knowing your requirements. What are the goals for the plastic parts? What is the end use? Is it industrial, consumer product? What environments you're going to be subjecting these parts to? Is it a cosmetic part, or is it a highly functional part that needs other considerations?
Well, thanks for bringing up that whole requirements thing. We didn't touch a lot on it in this particular webinar. We have touched on it in some previous webinars. But it's important to know where you're headed so you know when you get there. And requirements help you guide that. So, all right. Did we get one more question? Two more questions. All right. Let me see. If you have a part that has two pieces of a molded plastic that fit together to encase an object inside, such as a magnet, does that get assembled at injection molding location, or would that have to be done elsewhere?
So a lot of the injection molders will have like ultrasonic welders, and that would be a perfect opportunity for them to weld the magnet in place. And that would be a question for the molder.
So possibly, depending on who
Yeah.
you're working with. Yep. All right. That was actually just one question wrapped two corners. All right. I think that's all I see. But I appreciate all the questions, everyone. That's great to engage with you. This actually does bring us to the end of our 6th webinar in our Hardware Marathon series. Joe, thanks so much for joining me today. I think it's been insightful to hear what you have to say about injection molding and share some of your knowledge on that. We only have 2 episodes left in this series. Our next webinar will look at the initial production run of Pilot. I hope you'll all be able to join us for that. If you aren't on our mailing list about these webinars, drop us a quick note in LinkedIn and we'll work to get you added into our mailing list. So that way you'll be informed about what happens when the next one happens. In parallel with the webinar series, I've mentioned this, we are releasing blogs on each of the 7 phases and actually maybe a couple detours. Today's topic is already posted on our blog page at zebulonsolutions.com. As I mentioned earlier, this video will be on our YouTube channel. And if you'd like to get into contact with myself or Joe, please do so on the Contact Us page on our website, or you can send us an email at our general inbox, which is info, I-N-F-O, at zebulonsolutions.com, and just mention the webinar along with your question. Thank you all for joining us today, and we hope to see you again next time.